next presenter. I'm very happy finally to have a woman with us. We have AJ Hu from Astronergy Chint. AJ has been with Chint for a decade, and she had several roles in the company and is currently the product manager for solar, and we're very, very happy to have you present us about Astro 5S, the new generation of high efficiency residential modules. AJ, the floor is yours.
Hi everyone. Hi Michael. Thank you for the introduction. I'm very honored to do this introduction for our product. And as you tell, I'm already worked in Chint for 10 years. So maybe I can tell a little more about our product and especially for the new product. This is the first time we introduced the product. So now I can go ahead. Wait a minute, I can share the screen.
Share your screen, and then can you share the screen?
Yeah, wait a minute. Okay, can you?
Wonderful, thanks.
Okay. Today, my topic will be, we will introduce our new product. This is especially for the rooftop residential modules, it's new generation. And we called our new product Astro 5S. And today, the content will be include 5 parts. Firstly, I will basically briefly introduce Astronergy and the relation with Chint Solar, and I will introduce what the characteristic of the residential rooftop modules, and why we choose Astro 5S for this new generation module, and what the core technology is, and what the advantages, and also we comparing with the similar modules in the market, and to see how is the why it's perfect for the residential market. And also I want to give you some reference for the product reliability and also the reference. So this is our new product. This is the picture here. Okay, I come from Astronergy. Someone may not familiar with Astronergy, or someone may not familiar with Chint Solar. Actually, it's the same company. Usually, Astronergy is Chint Solar, and we were founded in 2006. For now, we already have 15 years history, and by this year, by the end of this year, we have 12 gigawatt module capacity and also the cell capacity. And currently, we have 3 manufacturing sites in China, and the headquarters located in Hangzhou, and another one is in Haining. And we have a new facility located in Yancheng, and was released 3 gigawatts for the new large wafer new generation modules there. 3 gigawatts released in Q1 this year. And also we have another factory located in Thailand. And for now it's a cell factory and also the module factory. 1 gigawatt new capacity was on building. Okay. Today my topic is for the residential rooftop modules. So it's very specific. For a residential rooftop, what kind of module will be needed for the residential rooftop? I would like to say there are 5 aspects. First, as we all know, for the rooftop, the area must be limited. Not everyone has a big family, a lot of roofs. So limited area, we want to install more capacity. That means we need high power modules. Of course, limited area decides the module efficiency. The higher module efficiency will be the better. Of course, if you want to install a module to the rooftop, of course you need to. We would like to see we need to easy to install. For this picture, you can see the people can carry one module, and we would like to see we need the suitable size and suitable weight and the perfect design for the rooftop modules. That will be very essential for the rooftop. And also, it also needed to have the good quality. You know, for a rooftop, you cannot repair, if you want to repair module or replace module, you need to climb to the rooftop. It's very hard for you to replace or repair. And of course, if the quality is not good, that would be a disaster for you to the family. So I would like to say, of course, you need to do high power module. Also, we need to the best provable reliability modules. Also, the longer warranty will be the better. So of course, usually we buy a product, we need to the higher power, the higher quality, and also we want to use the cost and the general cost that. And as the former speaker said, we need to calculate the BOS, the LCOE, so the internal cost will be the lower the better. And of course for the rooftop, it would be integrated with the building. So we must to say, if you want to use the module, it must be look beautiful. That's very, very simple, but very important for the rooftop market. So basically, the 5 needs will be very special and all essential for the rooftop modules. Why we choose H5S for the next generation? How it can to fit the 5 specs and how we design our module. I will to introduce you step by step here. As I say, I think Longi, the colleague already said, I also said similar. And according to, for a rooftop, definitely you need to support size and support design. And as our research, and take example as Australian market, and usually the request will be the roof is for the module size is for the roof is less than 1.8 meters, and in the Europe and the US they have the similar request, and also as the Occupational Safety and Health and Act of the United States. And one person cannot exceed 50 pounds when you carry the module. So that limited module, 1.58 millimeter length and 23 kilogram modules will be the best for the rooftop modules. So for us, we give very preliminary design with the large wafers, especially with the 182 and the 210 modules. We give different module designs, and we calculate the electrical performance and also the mechanical performance, and do check, as you can see, and 182 with 50 cells there, and 210 and 42 cells. These two will be fit the length and the weight request, but the power kind of low. And this with more cells, the weight will be to beyond the limit. So we would like to say to choose from the 2 designs. And why we choose 182 of 50 for this design for our H5S design. This will be our H5S. I would like to say, currently, as the other speaker says, the wafer, larger wafer means higher power. Why we choose 182, not the 166 at 210, and why the benefit of that? As you can see, comparing to 166, the power, one piece of the wafer, the power can be up to 6.3 watts. And the 182 millimeter wafer, the single power one piece is 7.6 volts. So if you want to the similar module power, that means you need more cells for the 166. I know Longi they are using 66 cells. More cells means more cell gaps, because cell and cell indeed has more gaps. So the module efficiency will be affected, and also the manufacturing cost will be higher than the 182. But why we don't choose 210? Because as you can see, this 210 wafer, of course, it has the highest power. And but if you want to cut into half, and the current will be much higher, and that will be limited by current, the many components of the module, and also the inverter adaptation, and also the weight and the size requested will be limited here. So, and also we need to, if you cutting that in triple times, so the current will be lower, but more cell classes will, how to say, to be more complicated. And also for 210 wafer module design, they have a completed circuit design for the rooftop module specific, because they have 6 columns, and so comparing to 210 millimeter wafer, and we think 182 has major technology and have reasonable circuit design, so we choose 182 for the wafer option, and for 182 with plus for 54 cells with the basic module design here. Okay. And why we can say H5S will be the gold perfect for the rooftop. Firstly, how we can get the high power, and I want to introduce the core technology. Of course, is the heart of the module. The high efficiency cell will be the most important. For in Chint, we have been working, have been dedicating the cell efficiency improving. For currently market the PERC also will be the dominant, and we have already now for us we already have the 4th generation PERC. And the power, the mass production efficiency of the cell already more than 23.2%. And you can hear here we use the very high efficient bifacial solar cells will be through different process, all the from etching, the LED, the diffusion, all the process, we got a lot of improvement on the cells. So we want to use the highest solar cell for the module to get the highest power. This is very important. So of course, for the module design, we have some very good design to also to help improve the power. Maybe someone, most of the people are already familiar with the half-cut technology. I want to repeat here. So with the half-cut design, as you can see, the current will be only half of the current as the full cell modules. So with the current reduced, internal resistance will be much lower. So the power will be improved greatly, at least 2% will be gained. And of course, since the current, you know, in outdoors, in the fields, small shielding can lead to the very high temperature of the hotspot. But since the current is also lower only half a bit, so the hotspot temperature will be greatly reduced and at least 10 or to 20 centigrades. So this reliability will be enhanced and the risk of hotspot will be greatly reduced. Of course, the current also leading to the LCT will be much lower, with help for the reliability. And if something happens on the shading loss, in the portrait installation, only half of the module, the below half, second half can be affected. So the shading loss can be much lower. And so we can see with the hard cut technology, not only to improve the module power, and also we enhanced module reliability here. And also for Astro 5S, we also use the MBB technology, multi-bus bar. You know, traditionally we use the full cell. But what's the benefit with that? And for Astro 5S, we go with the 11 bus bars to go with the round ribbon. And you can see here, with the multi-bus bar design, the optimal performance will be greatly improve. You can see the utilization. More light can be reflected in different angle with the round wire. So in this case, the light will be used more fully. So we can see, and the power will be also increased at least 2% here. And also with the multi-bus bar, and the current collecting path will be much thinner, and which means the cell has better ability to collecting the current. So the resistance will be reduced. So and also with the multi-bus bar design, all the crack can be limited in a small area. So the crack risk can be lower. So in this case, the anti-cracking ability will be improved and the reliability will be enhanced. So with this multi-bus bar, also we got higher efficiency and better reliability. And another core technology how we use for Astro 5S is differently with other modules. We use the non-destructive cutting technology for the cell cutting, because we use half cut design, so we need to cut the cells into 2 pieces. So we use cutting. Traditionally, they use multiple cutting. And what's the benefit of it? You can see from the picture from the SEM. And with the multiple cutting, the more damage laser cuts can be seen, and the damage to the substrate, the more cracks can be here. And with the non-defective cutting, because maybe the cutting, the cold water can cooling the temperature, and you can see the smooth. The damage will be much lesser, and the smooth selection and no micro cracks. And of course, with lower temperature, and of course for the multiple cutting, the HeightAffected Zone can be up to 80 to 150 micrometers. You know, wafer is very thin, but this HeightAffected Zone is very large. So without the high temperature, non-destructive cutting can reduce the loss caused efficient loss caused by the cutting, and also the power can be improved at least 1 watt, and according to our testing. And in the meantime, and the bending length, and you can see the picture here. And after with the non-destructive cutting, the bending will be much less, and the bending length can be much improved with the non-destructive cutting compared to the multiple cutting can be up to 30%, even to compare to the full cell, at least 10% can be added. So with the bending length, which will be very helpful to reduce the cracks. Of course, it can enhance our modules mechanical load performance. in our load performance test, the power loss can be less than 1%. That means makes our H5S modules can be flexible with different mounting systems, more compatible and more load performance facilities for the rooftop modules. So here we use the non-destructive cutting, not only improve the power and also for the reliability, the capacity also can be improved. So we also have another technology called core technologies high density design. As Michael just asked the questions about the GA colleague, the speaker there, and they say what's the different method of the welding process. And actually, in the traditional one, they use the ribbon bending process. Usually, the cell gap will be around 2.2 millimeter here. And some may choose the negative foot spacing, and the spacing can be even be negative, and the cell can be to be overlapped by another cell. And but with this process, the correct will be to much more, and the yield rate can be affected. Also, the reliability of the modules, I think, will be affected by this process. So for us, we choose a small basing technology. That means we use this intelligent welding and ribbon shaping process, and to limit the cell gap from 2 millimeter to 0.5 millimeter. That means smaller basing, and we can get a higher module efficiency. And at least with the technology, we can get at least 3% module basing can be improved. So with this high density design, we can see our module efficiency will be greatly improved. Higher power, higher module efficiency. That's we got the best welding, and also to get a good reliability comparing to the negative spacing process. Okay, and another technology for our H5S, we call the double layer coated class. And this is for the material. And for the traditional coated class, usually it's one layer. And for us, we use the high permeability double layer AR coating class. And you can see here there are 2 layers, and 2 layer has if you use reasonable coating thickness and refractive index, we can improve the light transmittance at least 0.3%. And also with the second layer, the dense diode silicon layer here, and the water can be excluded by the glass and insulate the water vapor. The water vapor will be excluded. So the reliability for the environment, for the weather resistance can be improved. So with this technology, we also can get higher data transmittance. That means we get higher module power and also better reliability. Okay, and now I already introduced different technologies here for the H5S. That means we got the higher power, but why we choose 182 full cells? What's the advantages compared to the current market module designs? As you can see here, and we take 2 very typical designs from the market at 150-60 cells and 201 and 40 cells here to do the comparison here. And for the 166 cells, and the power efficiency, because they have more cells there, the module definitely will be larger, so the length will be longer. So as I already said before, with the small wafers, so the efficiency, more gaps, so the efficiency can be effective, so the efficiency will be lower. So for us, we choose 182 for 54 cells here. The efficiency, the power can be 415 volts, and the efficiency can be around 21.5%, and the size is a little bit smaller, definitely smaller than this design. So, and we would like to say we have a proper length and weight, and why we don't choose 210/40 cells, as you can see here. And 210/40 cells, and the power will be lower than our modules. So of course, power lower and the efficiency will be lower, and the voltage will be higher, and that means less modules can be connected. And also, we have the similar weight and the similar length, but this module design is symmetric. So the aesthetic not looks so beautiful. So we would like to say, so comparing the two designs, we think 182/44 cells is the best design for our rooftop modules. Here. And also, we also comparing to the system capacity. As the Ariel said, for American family, a typical rooftop area is 42 millimeters. So we calculate from 35 square meter to 49 square meter, the roof. We calculate a different area and to see the system capacity can be changing. As you can see here, with Astro 5S modules, the orange line here, we got the highest power generation because we have the best module power and efficiency. And comparing to the 166 design, we can get at least 5%. And for the 210/40 cell design, we can get higher 2.5% power generation for the same roof area. And so also we're comparing the BOS. And on this page, and usually for the 166 is $2 per watt for the BOS. And with our Astro 5S, and you can see the orange line, it's the BOS definitely lower, the lowest, and is comparing to the 210, and you can be 5 cents can be saved for the BOS per watt, which is a very large number, and for compared to the 166 design, and it can be up to 11 cents per watt. You can get much lower BOS cost. So of course, we have the best design where we have the lower cost, and how is our module the quality would be like, and we can see how Astro product in the behavior in the past. And you can see our module not only to pass the very strict internal test, and also we send to our modules to the third party such as PVEL, and we have been got fourth times for the top performer, and also this year we already got the fifth, not officially to release, and I think which proves our modules reliability. And in last year, even our Astro product, even which is the only one who won the 5 all-round test sequences, the extended TUV test sequences, extended REC tested, and according to the PVTech's the listing, and among all the manufacturers, Chint Solar was listed #1. And we got the most quantities of the top performer awards here. And also in last month, Astro we in the TUV Greenland, they issued us for the All Quality Matters Award. For us, for our modules and for the monofacial build area and bifacial area, we got 3 awards for the energy yield simulation and also the module efficiency. This which proves our modules high efficiency and also here and also our quality. That means you go and have the best quality, you got the best yield simulation. Of course, for the that is for the extended test, and also we also do the outdoor demonstration. We send our module to Tibinot in the Ningxia province, which is a very dry and hot climate. Our module there was after 13 years, the degradation was less than 1% and 1.3%. That means which greatly to lower than our product warranty 2% for the first year. So that proves in the different in this strict climate, our module has best performance there. And also we also put our module to the Hainan, very wet and hot climate there, and also very good results. And after the first year degradation was 0.58%, and even in north or south in different climates, our module have very durable reliability performance to show. So let's conclude here. Why I would like to say ISO 5S will be the perfect for the rooftop. As I can say, our module can be up to 415 watts, and we got a very high module efficiency, it's almost 21.5%. And we can, with this high power, and we can install more modules. And of course, all the module design will be very suitable. We limited our module into a perfect design, and for most of the market requests, and for the dimension and weight. And also, we have the very good reliability, because we use the technology not only to improve the module power, and also to improve the reliability, and also connecting to our intelligent manufacturing process. And we have tested in different third party DMAGL, and also T-Renault, and that makes us very confident with our product warranty. So for this product, we give a 12 years product warranty. Even with the optimization of the BOM, we can give 15 years product warranty for this product, longer warranty, because we also use the standard warranty for the first year will be less than 2%, and the second year to the 25th year will be less than 0.55%. So with high efficiency and high quality, and also with different design, the typical design of the roof, we have lower BOS. And of course, for our modules, we use this module is higher, but we use 30 frame design, and we can make per high quilt can install can put 936 pieces there. That which makes for the transportation will be slightly too low, especially in the current market. The transportation cost will be higher. So and of course the transportation will be lower here with the H5S design. And of course, the H5S is very beautiful, and it's symmetrical, and you can make it black. You see the picture here. It can be pretty included with the rooftop, very beautiful. So we can see our H5S. It will be it's born for the rooftop. So that's the basic. We can surely make it suitable and perfect for the rooftop. Okay. Last, I want to one more pages to introduce Chint, because in China, as you know here, and we have a different commercial mode with in the residential market. And for now, we have already installed 400,000 households there, and we have been the #1 in the house code market, in the residential market. So I think we have many how to say skills and advantages in this market. So we think with our experience and also the combining the technology, we think H5S will be how to say. Today is the boring day, so obviously we will be perfect, and we can say and will be perfect for the rooftop, and I hope and more rooftop can use our H5S. Okay, that's all for today for my presentation.
Thank you, AJ. That was very enlightening, very nice presentation. Let's maybe have, I think we are almost in time, but I would like to ask quickly two questions. One was, you mentioned you're using bifacial cells in a module. Why are you making your PERC cells bifacial before you put them in a monofacial module? Well, where are the benefits?
Actually, can't and how to say, I think to go to this specs first is about for the efficiency. I actually use the bifacial cells, and it really can some power can be gained. And so with the bifacial cells, even the module you can see is without ladder, but with the bifacial cell design, the monofacial modules can be gain more power. And of course, with the bifacial cells, and because the silver piece, the aluminum piece can be saved, so the cost performance will be improved.
Okay, super.
Yeah.
Okay, one more question actually, because I think you showed your 4th generation PERC cells, and I think the efficiency you mentioned was extremely impressive, with 23.44%. Is this a traditional PERC cell, or is there some passivation mechanisms included in this cell? Because it's so high. Also, the voltage was very high. It was close to 700, which you rather have not for PERC traditional.
Yeah, for us, of course, because I didn't put many details here, because sometimes it's confidential, but I would like to say, basically it's the traditional polar cell, but we did a lot of improvement on different process. Every process we make it the best, and we did a lot of try, testing, and all day to improve the cell efficiency. And also all the cell equipment and facility will be the latest, so it will also be helpful. Yeah.
Okay, super, but very exciting news.
Yeah.
Okay, thanks so much. And then, yeah, so I think your team is actually already active answering questions. Your colleagues are very active. That's great. So we continue then with the final speaker before we start the panel. So stay with us.